Chat. What is up? I need. I'm just sorting out some work stuff. Like just have to check in. I have to check in. That's great. I'm checking something which I need to. So just I'm gonna talk till then. We're gonna maybe wait for Shashwat to join. I'm not sure. And I think also water went into my eyes. It's a bit red for some reason, but we're gonna work with that as well. So yeah, we're gonna work on Pipecast today. I think it's good enough to start the implementation. In the sense, like I've not planned it properly, and I should probably do a better job at that. But we're gonna figure it out stuff. I'm gonna after today's stream, I'm gonna know what to do for the weekend. So that's something I look into. But today's Thursday, we need to be consistent with the streams. Even if you stream for half an hour, at least it's a stream. So I'm just checking something, some work stuff. Just give me a few minutes. Just a few minutes. Mm, Ooh, brother. Yeah. And I hope all of you are hydrating yourselves. So that's that's the aim. Sure. Oh, oh, that's crazy. That's crazy. Oh, that's crazy. That is so crazy. Anyway, that's gonna be a fun inside. Um, uh, yeah. Uh, man, I can't really. I don't know if I should say it on screen, but it's better if we don't. Uh, so, yeah. Um, yeah, I think everything else is good. We can keep the go ahead. Um, Whoa, brother, stop, stop. Mm-hmm. Um, okay, interesting. Mhm. Um, um, I'm sorry, Chad. Just 5 minutes. I'm just gonna wrap some stuff up. Yeah. We're gonna actually let me spin up the project also. Pipecast? Is it Pipecast? It's Pipecast. It's Pipecast. Dude, I've already called it like version 0.1. So anyway, yeah, let's see that. You know. Anyway, I think my eyes also getting better. Like it's not red anymore. Um. Okay. Sure. Um, all right. This is funny. Uh, um, uh, yeah. Okay, that's good. That's good. Okay, I can do that tomorrow. Okay, we're back. We're so back. We're so back. Okay, I need my headphones. Oh my god. Oh my god. Okay. Okay. We're gonna listen to music. We're gonna cook. We're probably gonna work on the front end. Maybe. I know. It sounds boring, but guess what? We have um, we have a lot to do. I'm just putting some songs for myself because I'm feeling energetic. So, brother. Oh come on. Oh, we're so bad. We're so bad. Oh, we're so bad, dude. Yo, Saitama, what's up? Saitama, do I know you, Saitama? Is the question. Let me just man. Okay, I'm gonna share my screen finally after 7 minutes. Hopefully everything is there. Oh, let me just actually. Yeah, we're good. Actually, I can remove that. So here's the thing. Let me just share my screen. That is not my stream setup. Okay, I don't know how long we're gonna stream because it's already like 11:30, and I would like to sleep early. So 11:30, I'm saying sleep early. But we're gonna just let's see, let's see. Okay, so here's the thing: we're making a streaming software, right? I have no idea how much we've already done. So that's what we're gonna figure out. Can you spin up? Oh, nothing. Literally nothing. That's great. That's actually good. Also, I don't want to use Claude here, which I've generally not been using Claude other than like front end stuff. But the thing is, for the front end, I want to set up the layout and do the state management and the rendering part myself. But for the UI, I'll probably use Claude. But the things I don't really care about, I'll probably use Claude. I recently joined the Discord group, so probably know. Oh, Builders Inc. Are you talking about Builders Inc? Yes. Delivering live YouTube content via RTMPS. So this is how it usually works, right? The general idea, which I've talked about in other streams. Yeah. Well, welcome to the stream, man. So, okay, to give you context, we're making our own streaming software because right now I'm using this thing, StreamYard. I don't want to use StreamYard. Plus, it seems like a fun thing to build. So, we're going to be making our own streaming software. It's going to be an Electron application. Maybe I'll shift it to something else tomorrow. But right now, we want to be able to. This is the goal. This is the goal. Where is the text? We want to be able to stream to YouTube. We want to be able to stream to Twitch. That is not the spelling of Twitch, and that is also not the spelling of Twitch. And then we want to be able to stream to Twitter for some reason because Shashwat keeps telling me to stream on Twitter. We need to do this at the same time. So that means there's probably some sort of strategy pattern we're going to use. And then what else? Yeah, I think we then this is interesting because we're also going to focus on like buffers and then performance and like how much lag time you'll have to face. The protocol you use for this is something called RTMPS, real time message something protocol. It's over here now. Dismiss. I don't want to watch that. What is RTMPS? Yeah, real time messaging protocol, and S is for secure probably. So it's pretty simple. Basically, you have your UI. Okay, right now when we're streaming, this is let's say us. This is let's say chat. Nice little blue color for chat. This is the video frame that is being recorded, and each second that goes by, there's like each second a buffer is captured, right? The screenshot is captured. You take the picture, you convert it into a buffer, and then you would basically, on a desktop level, this is let's say the renderer process. I need to zoom out. Oh, there you go. This is the renderer process of Electron, right? Because well, it's rendering a UI. This will be sent to the through IPC. It will be sent to the backend process. I forgot what it's called. What is it called? What is it called? Source. Yeah, main process. It's called main process. So this will be sent to the main process, being like, hey, this is my video frame, buffer or whatever. Here you go. What we'll do on the main process is we're going to convert this with FFmpeg, by the way. I am so bad at writing with my right hand. FFmpeg. Yeah, amazing handwriting, dude. Anyway, we're going to use FFmpeg. We're going to somehow convert that buffer stream into RTMP. I hope I'm saying the right terms. Like, I'm not sure if it's a buffer stream. I'm guessing it's a buffer stream. We're going to convert that into RTMPS format, and then we're going to blast it off to YouTube, Twitch, and Twitter at the same time. That's the idea. This is the whole project basically. That is just left out. This is the whole project basically. This is what I want to build out. So yeah, let's see. I'm also not sure if like I have all the components I need, but we also probably might want to think of how to set up the UI because this is important for me. The fact that if you're making our own streaming software, you want to customize it. So naturally, I would want green screen if we're talking about this thing. So something like this is what I would like, brother. Yeah, and like right now, if you see this chat, this is chat, like this part, and this camera thing is covering this. I don't want that. If let's say my camera block is like this, I want chat to be like a overlay, So that's like something I want to do. Not have it like covered by the camera. I want it to be like an overlay that I can put on front of the camera. So just more engaging that way, and I can move around the chat and blah 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 blah. So it would all be cool to like. So StreamYard merges the chat of YouTube, Twitch, and whatnot. It would be fun to do that in the software also. So I'm not sure where to start, but that's what the stream is for. Anyway, you have all this. You create a connection. Socket library, okay. You know what would be crazy? If this is our main process, right? Main index. This is our main process where we're like creating the window and blah blah blah. What would be interesting is if this just we're using like something like let's say exec-sync, and we spin up a process called I don't know backend.go for like lack of a better file. And we're like, hey, the actual like stream rendering and processing and FFmpeg can actually be like the whole packet will be written in Go, but in the main process we're just invoking that binary or that process thing that hey, spin up the backend when you spin up the application, and main process is just going to invoke that. Could be interesting. Let's see. That would also depend on the performance, but anyway, streaming live chat. Oh, what? Guide into life of a broadcast. Okay, I need to probably. Yeah. As explained, getting started, guide, brother. To create and manage live events on YouTube, you will use a number of different types of resources that are defined as part of either the YouTube data API or the YouTube content ID API. Okay. The resources listed under YouTube live streaming API header are technically defined in those other APIs
but are listed separately because they are only used for live broadcast. I did not understand anything, but we ball anyways. YouTube live streaming API resources. This is This is a live stream. A broadcast is different than a live stream. So we'll open that. YouTube data API resource to upload videos. Ooh, imagine if we could make our own video. Actually, no, let's not. One thing at a time. Asset claim policy, video advertising, we don't care about this. Create and manage a live broad, we don't care about that. Create your stream. A live stream enables you to transmit your video to YouTube and it describes the content you are transmitting. Each broadcast must be associated with exactly one live stream. Oh, so you have to create a broadcast for a live stream? Call the live broadcast or insert method to add your broadcast to YouTube's schedule of live events. The live broadcast resource that you are inserting must define values for the properties listed below. You need the title, you need the schedule start type. Oh, please consider the following guide when setting up blah blah blah. If you want the testing phase, when you can view. Ooh. Okay. Huh. So you need to create a broadcast and then you'll create the live stream and then you're going to pass the live stream in the broadcast. That's what I'm understanding from this. Live streams limit title, frame rate, ingestion. This is so crazy, dude. This is going to be so fun. In fact, live streaming RTMPS to Twitch. And we search that. We come here and we come to Twitter also. Whoa. X, formerly Twitter. Yeah, I have all that. Oh, you need a verified account. I don't have a verified account. That's great. Oh, it's okay. You will generate an RTMPS URL, a stream key, blah 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 blah. OBS. Is there any Streamlabs? Oh, Streamlabs. Let's go. This is great. Okay. And this is for Twitch. Twitch ingest recommendation. Dude, let's go. That is not what we're let's going. Oh, but this is the stream key. Oh. Ingest endpoints. So interesting. Live streaming Twitch. Where is the resource for this? How to, that's a YouTube video. Prism. Why have I heard of Prism? I think the question is, we should probably make that. Brother. Read me? Do we want to read me? Let's do questions or like to-do.md. Right. To-dos. Question. Brother, where is Q? How does RTMPS live stream usually work? We want to understand how it usually works and then we want to implement it for one platform and then we'll scale out to another platform. So this is the roadmap. Make basic live stream implementation. Step 1, stream to YouTube. Stream to only YouTube, right? I think once we have this, then we can be like stream to Twitch and Twitter. I am not calling this X. What else? That is step 2, right? Let's start with this. So the question is, what do we work on today, right? Because there's a lot of things we can work on. I don't even know if we have shared CN. Do we have shared CN? We don't have shared CN. Can we ask Claude to add shared CN? I don't want to add shared CN. I'm just gonna ask Claude to add shared CN. Can you add in shared CN in this electron white template? Yeah. So Okay, using AWS as an RTMP server to live stream onto or to live stream. Interesting. So, how does I think this is just like a prep stream, which is fine. How does a live stream usually work? How does a live stream work? How does live streaming work? From the camera, it is first encoded, this encoded, blah 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 blah. Cloudflare video live stream. How does a video live stream work? Byte Go. Oh, perfect. Oh, dude, I love Byte Go. I absolutely love Byte Go. Okay, we capture our video, RTMP, SRT. We send it to the streaming server. Segmentation. This is a server. We don't have to worry about this, right? Oh. This is all done by the server, I'm guessing. And then there's this is the seconds latency. Oh, okay. Interesting. Video storage for replay and download. Okay. And then these are the view devices. 1 second. Oh, okay, that's fine. Well, yeah, that's funny. Okay, how do video live streaming? Oh, brother, so chaotic today. Okay, I don't understand this. How do video live streamings work on YouTube, TikTok Live, or Twitch? The technique is called live streaming. Did you guys know that the technique is called live streaming? Yeah. Anyway. Live streaming differs from regular streaming because the video content is sent via the internet in real time, usually with a latency of just a few seconds. The diagram below explains what happens behind the scenes to make this possible. Also, I hope I'm in the frame. Am I not in the frame? Do I need to come a bit closer? Brother. Let me just 1 second. Problem is my table doesn't let my legs like fit in, so I have to like do weird stunts to get like there. Yeah, this is better. Not bad. Not bad. Okay. So live streaming differs from regular streaming because the video content is sent via the internet in real time. It's live basically. Okay. Raw video is data captured by a microphone and a camera. The data, okay. So here's the thing. We don't have to just capture video and microphone data, like camera and microphone data. We want to make a canvas. I'm guessing we have to make a canvas where we export the canvas as a video and then we send that to the main process. So the video data is compressed and encoded. For example, the compressing algorithm separates the background and other video elements. Okay. After the compression, the video is encoded to such standards as H.264. The size of the video data is much smaller after this step. Are we doing this in real time? Like, is this something we have to do? Yeah. Just install it for me, brother. I'm just gonna go to do. Do we have to encode the video? Okay. Yeah. Step 3: the encoded data is divided into smaller segments. Isn't it already small? Usually seconds in length. Oh, okay. So you take all data, you encode it, you chunk it up. So it takes much less time to download or stream. Is this what causes the latency? Okay, actually, good question. What exactly causes the latency in streaming? Like, I know it's the whole thing of like, since the moment your camera captures the data to the moment your viewer gets, beach ka jo process is, that is the latency. But if you can reduce that, the only thing dependent on latency would be the network, the time it takes for the network to transfer the data, right? So if we can get the encoding and all, if we have to do it, if we can get it to very like less time, we're winning. And that's why we might just spin up a process from the main, like a Golang backend inside the main process, which is in Node. So something to think about. Mm-hmm. Yeah, I think we have to do the encoding because the segmented data is sent to the streaming server. The streaming server needs to support different devices and network conditions. This is called adaptive bitrate streaming. This means we have to produce multiple files at different bitrates in step 2 and 3. Oh. So, damn. Okay, we're gonna close the water bottle. This is what I'm understanding. Brother. This is our video. That is not a good box. Okay, we ball anyways. This is the video. Let's say this is the video. You make it into small chunks or whatever. You encode it, you make it into small chunks. These are your segmented chunks. Now, because you have to send it to different devices, you're saying that, hey, let's say this is one file. Make 3 files for it in total. This is your, where is it? The streaming server needs to support different devices and network conditions. This is called adaptive bitrate streaming. Yeah, this means we need to produce multiple files at different bit rates. Okay, so this is one stream, 3 different options for it, and this will all go to, where is it? One platform. So it will go from this, all these 3. It will then go to, let's say, YouTube. We're going to make that red or pink or whatever. And then we don't need to just support YouTube. We need to do YouTube, Twitch, Twitter. So YouTube, Twitch. Damn. Okay. The live streaming data is pushed to Edge server supported by CDN. The live streaming data is pushed to Edge server supported by CDN. Millions of viewers can watch the video from an Edge server nearby. Oh, okay. CDN significantly lowers data transmission latency rate. The viewer's devices encode deep. Oh, the viewer's device does it. I had no idea. Crazy. If the video needs to be stored for replay, the encoded data is sent to a storage server and viewers can request a replay from it later. Okay. Standard protocols for live streaming include RTMP. Okay. Protocols for live streaming. RTMP. This is your real time. Whoa, messaging. Dude, I miss typing on my keyboard so much. Then we have HLS, which is HTTP live streaming. I think this is HTTP live streaming. Whoa, brother, where is my wire? Dash, what is Dash? Why is it called Dash? Dash reminds me of Incredible Crash. Dynamic adaptive streaming over HTTP. Dynamic adaptive streaming over HTTP. Okay. Dash does not support Apple devices. Oh. Does not support Apple devices. Okay, and HLS does. It requires the H264 or H265. Oh. Apple only accepts HLS, requires encoding of H.264 or H.265. Brother. And then we have Macromedia. Hey, isn't Macromedia... didn't Macromedia make JavaScript? Isn't Macromedia the one who owns a lot of the stuff? Okay, anyway. To transfer data between a Flash player and a server, now it is used for streaming video data. Now, note that video conferencing applications like Skype, use RTC for lower latency. Why can't we use RTC? What's the difference between RTC? Okay. Difference between RTMP and RTC. Okay. So is it like we do a fallback? I'm not sure. Whoa, brother. I don't want that. Okay. Anyway, both HLS and Dash support adaptive bitrate tuning. HLS and Dash support bitrate streaming or adaptive bitrate streaming, right? Brother, what? Why is it like that? Okay, how do search engines work? Proximity service. What happens when you upload a file? Oh, this is like in general stuff. Damn, that's it? Very nice. Wow. From Streamlabs desktop, brother, I don't care about Streamlabs. Sorry, Streamlabs. But I need to make my own Streamlabs. Yeah, this is great. XRTMP. Yeah. Oh, create broadcast. Okay. Oh, very good. I'm sleepy already. Damn. Ending the live stream. Okay. This is something we have to be careful about. I don't want to like mess up on that. But videos get bad insert update. Oh, I don't really care about videos. Live stream. Yes, a live stream resource contains information about the video stream. Dude, I'm so hungry. Anyway, about the video stream that you are transmitting to YouTube, the stream provides content that will be broadcast to YouTube users once created. A live stream resource can be bound to one or more live stream resources. What? Once created, a live stream resource can be bound to one or more live broadcast resources. Okay. Okay, create a video stream. This enables you to send your video to YouTube, which can then broadcast the video to your audience. Updates a video stream. If the properties you want to change cannot be updated, then you need to create a new stream. Okay, delete a video stream. This is probably what we want. Insert. Delete is something we can. Oh man. Delete is something you can do later. The following JSON structure shows the format of a live stream resource. Oh, it's a YouTube live stream. E tag mentioned. Caching, brother. ID, snippet, blah blah blah. CDN status. This is good stuff, dude. Yeah, E tag. What? Oh, this thing is default stream. Okay. How default streams work, blah blah blah. I don't really care about that right now. Oh, okay, that's great. We might want to think about like resolution, right? Like different bit rates basically. So let's note that down. Is that it? Claim your content. Damn. Okay. Before even we implement the live stream, we need to implement the closing of the live stream. Oh, this is actually good stuff. I should look into this more. Find API. YouTube has open source projects? Brother, don't mind if I do. What? Oh, okay. Damn. Holy wow. Broadcast and streams, ingestion protocol comparison. Okay. Oh yeah, there you go. Brother, it is 12. I am not going to lie, I'm a little bit sleepy. I would like to sleep early. We've streamed for a little over half an hour. This is great. I think this is a good start for this. I think we can like change the stream name or something to planning. Planning a streaming software, yeah. So let's call that planning heuristic. I think this is like a good start. Something you want to keep in mind. I will research more on like all this stuff so that next stream we can just like get into coding. So that's research I'll do on mine more. I did not know that was a thing. But yeah, this is good stuff. I think like good research. Anyway, but I am also very tired and I'm also hungry, so I'm gonna eat something and then I'm gonna sleep. But yeah, so see you on the weekend. So I will stop sharing. Boom. See you on the weekend. Bye YouTube.